Have you ever been amazed by the lightspeed scenes in Star Wars movies where the spaceships seem to disappear as they travel at extremely high speeds and appear again when they slow down? Even though this is science fiction, the contraction of spaceships that we see can actually be grounded in reality, specifically in Einstein's special theory of relativity, which states that there is no absolute frame of reference, meaning that time and space are relative depending on the observer. One aspect of this theory is length contraction. Length contraction is a phenomenon in which a moving object's length is measured to be shorter than its proper length. But what does this mean? First, let's define some terms. The proper length refers to the length of an object measured at rest by a stationary observer or by an observer moving at the same velocity as the object. The shorter length, called relativistic length, is measured by a stationary observer relative to a moving object. In other words, if an object at rest has a length of 1 meter, it will have a measured length that's less than 1 meter when it's moving at a very high speed from the perspective of a stationary observer. To illustrate this, picture two people standing some distance apart. They try to measure the length of a skateboard from two different perspectives. Person 1 is skateboarding at a constant speed and person 2 is standing still. Since person 1 is moving at the same velocity as the skateboard is at rest relative to person 1. Therefore, the length that he measures will be the proper length. The length that person 2 measures will be the relativistic length. If person 1 measures the skateboard to be 1 meter long, person 2 will observe that to him the skateboard is less than 1 meter long. The relativistic length will always be shorter than the proper length. If we were to explain the light speed jumps in Star Wars with this concept, it would be that the spaceships actually contract as they increase speed significantly, becoming flattened like pancakes when they approach the speed of light, and then decompressing as they slow down. It is important to note that length contraction is only noticeable when the object is moving at relativistic speeds, that is, extremely high speeds comparable to the speed of light. The amount of the object's contraction depends on the object's speed relative to the observer. The faster the object is moving, the more it will be contracted, and the shorter it will appear to the stationary observer. For example, a 200-meter spaceship will have a relativistic length of 199 meters when it's traveling at 10% of the speed of light, but its observed length will decrease to 100 feet when traveling at a velocity that's 86% of the speed of light. Its height will stay the same since contraction will only occur along the object's direction of motion. That is to say, if the object is moving horizontally, it will only be compressed horizontally while its vertical height remains the same. A common misconception about length contraction is that it's an illusion. But no, length contraction is a real contraction. This has been experimentally proven by particles accelerating at very high speeds. But if vehicles can actually be compressed, won't the people inside become squished? The answer is that they become contracted along with the ship. In fact, they won't even feel the contraction because according to their frame of reference, they remain the same, but everything else is elongated. To recap, length contraction is a concept in which an object approaching the speed of light becomes compressed in its direction of motion. It's amazing to think that space is not absolute but relative depending on the frame of reference. But like Einstein said, time and space are modes by which we think and not conditions in which we live.